Okay, let's walk through this Unit 3 differentiation application multiple choice worksheet, AP review. Number 1 says the slope of the curve y cubed minus xy squared equals 4 at the point where y is equal to 2 is, so we're trying to find the slope, we're trying to find a derivative at a point. We're going to have to involve implicit differentiation and product rule. Okay, so implicit differentiation and product rule. So let's see here. Y cubed, we can do power rule. Y cubed becomes 3y squared dy dx. But the negative x and y squared, we have to go through product rule there. So I'm going to identify the parts that we have to make sure we have. So f prime, which is negative x's derivative, that's negative 1. And y squared is the original g function, no changes, plus negative x, the original f function, no changes. And then y squared, we need to find the derivative, g prime, so y squared becomes 2y. And we ask for y's derivative, so we need to attach dy dx. Careful, the 4 also gets affected, doesn't stay 4, 4's derivative is 0. So now we clean this up, we get 3y squared dy dx minus 2xy dy dx equals y squared. I'm just going to go ahead and keep the dy dx terms on the left, move the non-dy dx term on the right. We can factor dy dx out, divide the parentheses over, and now we have our slope formula. But notice that if I want to find the slope at this point, I'm going to need the x and the y value. But the problem only gives us the y value. So we're going to go back to the original equation to see if we can gather information about the x, the location of x when y is 2. So we can take our original equation, plug 2 in for y, and that will allow us to solve for x. So 2 cubed minus x times 2 squared, which is 4. So 8 minus 4x equals 4. 4 equals 4x, x equals 1. The order pair is 1, 2. We put this into our slope formula. We get 4 over 3 times 2 squared minus 4. That reduces to be 4/8, which is 1/2. Okay, number 2, the tangent to the curve is vertical. So again, we have to involve derivative. We're asking about the slope, but the slope that we're asking about is vertical. And vertical tangent is where the slope is undefined. And undefined we can find by looking at the denominator of the derivative. Okay. But first, let's get to the derivative. Again, we have to involve implicit, just like how we did with number 1. And we have to involve product rule like how we did with number 1 as well. So y squared, we're going to get 2y dy dx. Again, we do product rule for the negative x and the y. Okay, so there's my f, which is negative x, and my g, which is y. So f prime g plus f g prime, much like how we did number 1. And then the 0 stays 0. We factor the dy dx out, we move the negative y to the other side, and then we divide the parentheses over, we get a slope formula, but we're not asking for any slope, we're asking for where slope is undefined. So slope is undefined is whatever makes the denominator 0. So we have 2y minus x, we set that equal to 0, and this is not going to give us an original a constant value to begin with. If we set 2y equals to x, we're still left with a variable. So what we're going to do is we're going to take this and see which is the easier one to plug in so that we can solve for, actually we need to solve for y because all of our answer choices is in terms of y. So I'm going to get rid of x. So to get rid of x, I can say x equals 2y. So y squared minus 2y times y, which is y squared minus 2y squared, which is negative y squared plus 9 equals 0. Negative y squared equals negative 9, y squared equals 9, and y is equal to plus or minus 3. That's answer choice D. Okay, number 3, we have a function, polynomial, and all the answer choices is asking about relative max, relative min, and all that is going to come from the first derivative function. So we're going to go through the first derivative test. So we go through power rule for each of these terms. X to the 4th becomes 4x cubed. Negative 4 squared becomes negative 8x. We can factor the 4x out. We're left with x squared minus 2. we can find critical points by setting each of these terms equal to 0. 4x equals 0, so that's x equals 0. X squared minus 2 equals 0. We get x equals plus or minus root 2. We take our three x values, we put them onto our sign line, and then we test each interval. Here I can plug in negative 2. Here I can plug in negative 1, positive 1, and 2. And all into the original, all into the derivative function. So if I plug negative 2 in, I get negative times positive, which is negative. If I plug negative 1 in, I get negative times negative, which is positive. If I plug positive 1 in, I get positive times negative, which is negative. If I plug 2 in, I get positive times positive, which is positive. So this will give me information about the slope. I know my graph is going to be falling to a relative min at negative root 2. It's going to rise to a relative max at 0. It's going to fall to a relative min at root 2, and it's going to rise again. So answer choice E. Okay, number 4, the number of inflection points of the curve in question 3 is, so inflection point comes from the second derivative function, so we're going to continue with moving on from f prime to f double prime. So we're going to find f double prime, we're going to set f double prime equal to 0, and we're going to create a sign line to see if there's a change in sign at these critical points. If there's a change in sign at these critical points, then we know that there's a point of inflection at those points. So f double prime, we go through power rule, we get 12x squared minus 8. We can factor the 4 out. Look for critical values. The 4 doesn't give us anything. The 3x squared minus 2, we set that equal to 0. We get 3x squared equals 2, x squared equals 2/3. So x equals plus or minus root 2 over 3. We place negative root 2 over 3 and positive root 2 over 3 into our second derivative sign line. We're going to choose values in each interval to plug back into the second derivative function. So negative 1 plugs in for x, we get a positive number. So that we know that portion, that part of the graph will be concave up. If I plug 0 in, I get 0 minus 2, which is negative, so concave down. If I plug 1 in, I get 3 minus 2, which is 1. That's positive, so concave up. So concave up to concave down, we know that critical point must be a point of inflection because there's a change in sign. And then from concave down to concave up, there's a change in sign as well. So we have 2 points of inflection, one at negative 2 root 3 and one at positive root 2 over 3. All right, maximum value of the function. So maximum value is the y value. So if I want to find the maximum value, I first have to find the critical point. So critical point, we're going to find f prime, and then from f prime we set equal to 0. I'm going to take that root 2 minus x and rewrite it as a parentheses to the 1/2. I can go through chain rule. Outside's derivative times inside's derivative. So outside's derivative, we take the 1/2, bring it down, multiply by negative 4, we subtract 1 from the exponent, and then we multiply by the inside function's derivative. So 2 minus x's derivative becomes negative 1. We clean this up, we get 2 over square root of 2 minus x. No critical point from the numerator, but the critical point from the denominator is going to be at x equals 2 when we set the 2 minus x equal to 0. We plug 2 in for, so we know there's a critical point there, and that's going to be our maximum value, but it's going to have to be the y value. So we plug 2 back into the original function. 2 minus 2 is 0. 0 times negative 4 is 0. So our maximum y value is at 0.